Have you ever looked up at the night sky and just wondered, how did all of this begin? For decades, the leading story has been the Big Bang, a colossal explosion that kicked off everything we see and everything we are. But what if I told you that story has a major plot hole? A mystery so deep, it makes some scientists question if we've got the beginning of the story all wrong. Today, we're diving into the lithium problem, a cosmic puzzle that challenges the very foundations of the Big Bang theory. Imagine trying to solve the most complex jigsaw puzzle ever created, but you're missing a crucial piece. That's what cosmologists face every day. They're trying to reconstruct the first moments of our universe, a time so extreme and so ancient, it's almost beyond human comprehension. The Big Bang theory is our best explanation for how the universe started. It says that about 13.8 billion years ago, the entire universe was squeezed into a point of unimaginable density and heat. Then, in an instant, it began to expand. Think of it like a cosmic firework, but instead of sparks, it created space, time, and all the matter and energy within it. As the universe expanded, it cooled down. In these first few fiery minutes, the basic building blocks of matter, protons and neutrons, started to fuse together. This process, called Big Bang nucleosynthesis, cooked up the first elements. Our models predict exactly how much of each element should have been created. And for most of them, like hydrogen and helium, the predictions are spot on. It's an incredible triumph of modern science. But there's a catch. One element doesn't fit: lithium. Our theories predict that a certain amount of lithium should have been forged in the Big Bang's furnace. But when we look out at the oldest stars in the universe and measure the amount of lithium they contain, we find only about a third of what we expect. Where did the missing two-thirds go? This discrepancy isn't a small rounding error. It's a huge gap, and it's known as the cosmological lithium problem. It's like baking a cake. You follow a recipe that calls for 3 cups of sugar, but when you taste the finished cake, it seems to have only 1 cup. Did you misread the recipe? Did the sugar somehow disappear during baking? Or was the recipe wrong from the start? That's the dilemma physicists face. So, what could be the answer? Scientists have been wrestling with this for years, and they've come up with some fascinating possibilities. One idea is that something might be wrong with our understanding of stars. Perhaps these ancient stars are destroying their lithium in ways we don't yet understand. Maybe the hot, churning interiors of stars are much more efficient at burning up lithium than our current models suggest. It's a plausible idea, but so far, no stellar model has been able to fully account for the missing amount without messing up other predictions that we know are correct. Another, more exotic possibility is that the problem lies not with the stars, but with the Big Bang itself. What if there was some unknown physics at play in the early universe? Perhaps a new, undiscovered particle was present in that primordial soup. This hypothetical particle could have interfered with the nuclear reactions, altering the amount of lithium produced. Think about it. A ghost particle from the dawn of time, subtly changing the recipe of the cosmos. These ideas push the boundaries of known physics, hinting at a world beyond the standard model that we've worked so hard to build. It could involve concepts from string theory or supersymmetry theories that propose new dimensions and a whole host of new particles. If the lithium problem leads us to discover one of these, it would be one of the greatest breakthroughs in a century. And there's a third, even more mind-bending idea. What if the fundamental constants of nature, things like the strength of gravity or the mass of an electron, aren't actually constant? What if they had slightly different values in the early universe? Even a tiny change could have a massive impact on the amount of lithium produced. This would force us to rethink not just the Big Bang, but the very laws of physics as we know them. To hunt for answers, scientists are using some of the most powerful tools ever created. They point massive telescopes at the oldest stars in our galaxy, meticulously analyzing their light to get the most precise measurements of their chemical makeup. They're also using particle accelerators, like the Large Hadron Collider, to smash particles together at incredible speeds, trying to recreate the conditions of the early universe and maybe, just maybe, catch a glimpse of some new, exotic physics. One of the most powerful clues we have comes from the cosmic microwave background, or CMB. This is the faint afterglow of the Big Bang, a snapshot of the universe when it was just 380,000 years old. The CMB is an incredibly rich source of information. By studying its tiny temperature fluctuations, cosmologists can precisely determine the initial conditions of the universe. like the total amount of normal matter. And here's where it gets really tricky. The measurements from the CMB are incredibly precise, and they strongly support the standard Big Bang model. They tell us exactly how many protons and neutrons there were, which in turn gives us a rock-solid prediction for how much lithium should have been made. And that prediction is the one that's wrong. So, the CMB tells us our recipe is right, but the final cake tells us it's wrong. It's a direct contradiction, and that's what makes this problem so compelling. So, what's the takeaway here? Is the Big Bang theory wrong? Probably not. The mountain of evidence supporting it, from the expansion of the universe to the cosmic microwave background, is just too overwhelming to dismiss. It's far more likely that the lithium problem is pointing towards a piece of the puzzle we're still missing. It's not a crack in the foundation of cosmology, but a doorway to new discoveries. This is how science works. It's not about having all the answers. It's about finding the right questions, embracing the mysteries, and relentlessly pursuing the truth, even when it's inconvenient. The missing lithium isn't a failure of the Big Bang theory. It's an exciting clue that tells us the universe is even more complex and wonderful than we ever imagined. It's a sign that a new chapter in our cosmic story is waiting to be written. What do you think is the solution to the lithium problem? A mystery inside stars, or a hint of brand new physics? Let me know your thoughts in the comments below. Science is a conversation, and we all have a voice. Thanks for joining me on this journey to the edge of what we know. If you enjoyed this cosmic mystery, don't forget to like this video and subscribe for more deep dives into the universe. See you next time.